Hi there, folks. Today we're looking at proving parallel lines, so proving that lines are parallel. And to do this, we're kind of going to use those same postulates and theorems that we've been looking at that gave us the properties of parallel lines, but we're going to use the converse of all of those. And when you think about the idea of, remember, conditional statements and converses and inverses and contrapositives and the truth values involved there, sometimes the conditional statement was true and the converse was false, and other times the conditional statement is true and the converse is also true. And we know that these things become true when we start to look at things like definitions or some of our postulates and our theorems. We just have to be very meticulous about the nitty gritty, those little details of the theorems. We think of something like the same side interior angles theorem. We think, hey, same side interior angles, they're supplementary. And it's okay to remember it that way and think about it that way, but we forget about those little details of it's only supplementary if we have parallel lines. And so when you think about the converse of that, the way we typically think of it, the converse isn't true. If I have supplementary angles, not necessarily same side interior, all right? But if we remember all those little pieces, okay, where it has to be parallel lines, all right, if we have parallel lines cut by a transversal and I have supplementary angles, then those are the same side interior, okay? So we can kind of use that in a different way. We have to make sure that they're same side interior angles, all right? And then if they're supplementary, then we can say the lines are parallel. So we need those little details thrown in there, okay? So just keep that in mind. So first one, converse of the corresponding angles. Remember, with parallel lines, corresponding angles are congruent. So the converse is, hey, if corresponding angles are congruent, and again, we have to have all those little details. If two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So you notice it's kind of wordy, but again, the way we think about it is the same thing. Just make sure you have those little details, all right? And I'm going to go through these pretty quickly. If you need to write them down, please pause, all right? Pause the video, write them down. Alternate interior angles. Once again, if lines are parallel, alternate interior angles are congruent. So if I have the situation where two lines are cut by a transversal and alternate interior angles are congruent, then I can say the lines are parallel. So it's the same thing. We just have to make sure we have this situation with the lines cut by a transversal. Same side interior. Again, if we had parallel lines, we know the same side interior angles are supplementary. So doing that backwards, we have to have the situation where two lines are cut by a transversal, and then if same side interior angles are supplementary, then we know the lines are parallel, okay? So it's all the same stuff, but instead of saying, hey, if lines are parallel, I have this, I say if I have this in this situation, then I know the lines are parallel, okay? So same thing, but reversed. And then alternate exterior angles. We talked about this one, that alternate exterior angles were congruent. But now the reverse, if I have this situation set up with the lines and the transversal and the alternate exterior angles are congruent, now I can go backward and say the lines are parallel, okay? So in the previous postulates and theorems, we were saying if lines are parallel, I know this about the angles. Now we're saying if I know this about the angles, I know the lines are parallel, okay? And that's why we kind of go through these conditional statements and that kind of stuff. And our postulates and theorems weren't always necessarily stated as a conditional statement, especially the postulates, all right? But we want to think of them as conditional statements so we can think about, all right, is the reverse true? All right, and in this case it is. For example, if I look at something like this guy, determine which lines are parallel given each of the following, all right? And this is not a continuation. It's not like I know this, now I know this, now I know this. It's look at these individually. If I only had angle 6 is congruent to angle 15, do I know if any lines are parallel? So if I'm comparing angle 6 right here and angle 15 right here, if I look at that and say, okay, well, line L is the transversal, those are alternate interior angles. So if I know some alternate interior angles are congruent, then I can say that lines are parallel. And the two lines that I can say are parallel in this case are Q and P. Okay? If I kind of hit the reset button, so pretend I don't have the 6 and 15 being congruent anymore. If I only was given angle 9 is congruent to angle 13. So again, comparing these guys right here, angle 9 and angle 13. If I look at those groups of angles, that makes line P the transversal. And when I look at that, 9 and 13 are corresponding angles. So if the corresponding angles are congruent, it tells me that the two lines being intersected are parallel. So M is parallel to L. Okay? Next, it gives me 7 and 10. So let's think about 7 and 10. So angle 7 and angle 10. And when I look at those two groups, what line creates those two groups? What is the transversal? And see, that's the thing we have to be careful about here, is do we have the situation that gave us the congruent angles and the congruent and the supplementary angles and all that stuff? And the answer here is no. I don't have that situation. I don't have a transversal, all right? If I said the transversal is Q, well, Q doesn't create angle 10. Oh, maybe the transversal is P. Well, P doesn't create angle 7, all right? I don't have this situation where two lines are cut by a transversal to form those two groups. So I can't say anything here, all right? There's not enough information for me to make a determination about any parallel lines here. All right, so I'm going to just say not enough info. Maybe there's some parallel lines there, but I can't say for sure because those angles are not part of the situation that we discussed. Okay? And then if I looked at this, angle 3 and 5 are supplementary. So let's say 3 and 5 were supplementary. So here's angle 3, here's angle 5. If I think about how, what line can create both of those groups, it means Q is the transversal here. So got to identify the transversal. So Q is the transversal, which makes 3 and 5 same side interior angles. So using that in reverse, if I had parallel lines, those would be supplementary. If I have the situation and those are supplementary, it means that the two lines being cut are parallel. So M is parallel to L in that situation. Okay? But again, make sure you have the situation that we've been looking at. A transversal cutting across two lines. All right? That's when we can start to make those determinations based on what I know. All right? If I look at something like this guy, these questions are the best, all right? Everyone's going to be really happy that we're doing these. It says, find the value of x for which the lines are parallel. See, before, I would say these lines are parallel, find the value of x. Now I'm saying if the lines were parallel, what would be the value of x? But the approach is identical to what we do. See, if I said M was parallel to L, you would go, oh, well, let's see, those two angles, if I were to kind of transfer this guy here, these are vertical angles, so that's 111. And then we said, oh, those are same side interior, they add up to 180. So if I had parallel lines, I would know that those add up to 180. But that's not what I'm doing. I don't know that the lines are parallel. It says, if the lines were parallel, what would be the value of x? Well, if the lines were parallel, then these two things would add up to 180. If that were the case, okay? And so, again, it's no different. If I say that the lines are parallel, you would say these add up to 180. If I said if the lines were parallel, okay, then these would add up to 180. And now I solve it the same way that I've been solving these things. So combine like terms. I subtract that 120 from each side, and I divide by 2. So I get x equals 30. But the only difference here is before I would say x definitely equals 30. Now I say if x equals 30, then the lines would be parallel. All right? It's the same thing, but now we're solving it in a hypothetical situation is really the big difference. Okay? The work is not different. How we state the answer, how we talk about the answer would be different. Okay? If I looked at something like this guy, if I had parallel lines, if M was parallel to L, well, those would be corresponding angles, and corresponding angles would be congruent. And that's kind of what the question is asking. Like, if, all right, I want to know what value would make the lines parallel, what's the same thing as saying, the lines are parallel in terms of how you solve it. I don't know why I'm adding like a crazy person. These should be equal to one another. And again, we don't know that they're equal. We're just saying, if I wanted the lines to be parallel, these would have to be equal. So now here I subtract the 2x from each side. I add the 2. Done and done. All right? And I'm not saying that x equals 19. I'm saying if x equals 19, then that would make these lines parallel. Okay? It's the same work, but we state the question, we state the answer in a slightly different way. Okay? If I look at this guy, We're going to do a proof this time. So I'm given that angles 1 and angle 1 is congruent to angle 16, and I want to prove that Q is parallel to P. And here's the thing, when you first look at this, you're probably going, well, wait, 1 being congruent to 16, that was the same as that example earlier where I didn't have enough information to say anything, all right? And you're absolutely right. The trick here is look at the picture. There's more given than is actually stated over there, okay? See, there's one more thing that's given based on the symbols in the picture. And if you look over here, hopefully you see it, those little red arrows. Those little red arrows mean that M and L are parallel, so that's also part of my given, all right? And see, there's more than one way to state what's given. We can state it in the picture using symbols. We do that a lot of times with some of these things like parallel lines. And sometimes it'll also be listed over there. Just be aware of that. Or like the little box that tells you we have a right angle, okay? We can give things based on the symbols in the picture. So just be aware of that. Now we're ready to start this proof, okay? So we're going to do our statements and our reasons. And sometimes, especially with this one, it helps to kind of think about the end result that we want, all right? Sometimes with proofs, we just kind of start rolling with what we know. We start with the given and we start throwing down what we know and kind of hope we start going in the right direction. But with something like this, we want to prove that Q and P are parallel. So look at angles Q and P. If I'm looking at like the group of 1, 2, 3, 4, and 9, 10, 11, 12, I could use that group. And if I can show some of those angles are congruent or show certain angles are supplementary, then I could say the lines are parallel. Same thing, I could look at groups like 5, 6, 7, 8 and group 13, 14, 15, 16. All right. And if I can show certain angles from those two groups are congruent or certain angles from those two groups are supplementary, then I'll be able to say that the lines are, that Q and P are parallel. So kind of think about that. I want to relate certain groups together. All right. So let's start with what we're given. So I've got angle 1 is congruent to our good buddy angle 16. I also know that M is parallel to L. And even though one of them was stated over there and one of them is given in the picture, they're both still given. All right, so given is my reason. Okay? And then from here, I don't have to use both of these givens together. I might want to focus on one or the other. The idea here is I want to relate something from one of these groups to like maybe group 5, 6, 7, 8 to group 13, 14, 15, 16. All right? But I might have to use that first group to get it. So I'm going to do this route. And keep in mind, there are a bunch of ways that you can do this proof, okay? There are a multitude of ways. Yours could be totally correct and not look anything like mine, all right? But see, I see this. I look at this and say, wait a minute. I know that something like, I don't know, angle 1 is congruent to, and I could say angle 5, or I could say angle 8. All right, something like that. Or I could say angle 1, or angle 4, but that doesn't help as much. All right. But see, I know M and L are parallel, so I can relate group 1, 2, 3, 4 to 5, 6, 7, 8 very easily. Okay. And I could say that it's congruent to 5 because of corresponding angles, something like that. Or I could say it's congruent to 8 because of alternate exterior angles. Okay. So maybe the most obvious one is angle 5. Okay. So I'll say, hey, 1 is congruent to 5. And I know that because corresponding angles of parallel lines are congruent. Okay, that's one of the that's the postulate that we had the other day that says, hey, parallel lines, these angles are congruent. Okay, and now from here, if you don't see it, I just said that angle 1's congruent to angle 16, but then I said angle 1's also congruent to angle 5, which means I now know that angle 16 is congruent to angle 5. Okay? And see, if you read this just right, 16 is congruent to 1, 1 is congruent to 5, so 16 is congruent to 5. You could call that your transitive property. Okay? And again, the transitive property kind of, hinges on the way you state it. Some teachers will be picky and have you rewrite like this step 2 as, angle 5 is congruent to angle 1 so that we can kind of see that transition, or really rewrite that first one as angle 16 is, okay? I'm not going to be picky about that, okay? So I can say that because of the transitive property. Maybe some teachers would prefer substitution there. I don't know. But then for something like this guy, step 4, hopefully you see that I pretty much have this thing wrapped up. If I know that angle 5 and angle 16 are congruent, well, doesn't that relate two of those groups that I was talking about? Group 5, 6, 7, 8 to group 13, 14, 15, 16? See, now I have a relationship between that group and the relationship that 5 and 16 are congruent. Well, what kind of angles are those? Those are alternate exterior angles, which means if alternate exterior angles are congruent, I know the lines are parallel. My proof is done. This is the payoff step right here. Q is parallel to P, and I know that because I have the situation. I have two lines, and yeah, technically I should say, oh, two lines are cut by a transversal and the alternate exterior angles are congruent, therefore the lines are parallel. Like, that's my justification. It's that converse of the theorem that we just looked at. We can state this a little bit simpler if you want. Okay, I'm just going to say if alternate exterior angles congruent, then parallel. Okay, I'm going to abbreviate quite a bit. All right, and as long as I can understand what you're saying, as long as you have a reasonable justification, all right, it's obvious to me if you write that you understand the converse of the theorem. All right, that you have the situation, the alternate exterior angles are congruent, so therefore the lines are parallel. Okay, that's it. Let's look at one more proof. All right, given angle 1 and angle 6 are supplementary, I want to prove that M is parallel to L. All right, so all I know right now is 1 and 6 are supplementary. I want to prove that M is parallel to L. And here's the thing. We don't have any theorem that relates 1 directly to 6 being supplementary. But as you start to think about which things are supplementary in this example and which things are congruent if the lines were to be parallel, we can start to kind of think about how we're going to pull off this proof, okay? And so let's do our statements and our reasons. One, I'm just going to state the given here. Yeah, I do quite a bit of abbreviating. And I know that because it was given. Hey, those guys are supplementary. Good for us. Okay? But now think about supplementary. All right? I know that 1 and 6 are supplementary. What else do I know are supplementary? All right? And how is that going to help me? And you know what? There might be a ton of information here that's useless. Okay? So something like this. I might say, well, I know 1 and 6 are supplementary. But you know what? I also know that 6 and 7 are supplementary, don't I? Because that's a linear pair. So angle 6 and angle 7 are supplementary. And I know that because they're a linear pair. Okay? And again, we could state that in about 3 steps or so. All right? But I think we have a reasonable justification based on the description that I've been given here. Okay? Based on what I've been shown and all that. Okay? And then from here, if I know that 1 and 6 are supplementary, and I know that 6 and 7 are supplementary, all right, what does that tell me? All right? And see, we had a theorem a little while ago that related supplementary angles and said, hey, you know, if two angles are supplements of the same angle, then those two angles are congruent. Okay? And that's the situation we have here. So right here, angle 1 is congruent to angle 7. And I know that because, well, they're supplements of angle 6. All right? The supplement of angle 6 has to be the same no matter what. So if the supplement of angle 6 is angle 1, but the supplement of angle 6 is also angle 7, then angle 1 and 7 have to be the same measurement. They have to be the same angle. Okay? And again, that was a theorem we had. You probably don't remember the name of the theorem. I probably don't even remember the name of the theorem. Just state it in your own words, okay? It's reasonable justification. We know that there's a theorem that exists. Just state what the theorem is. Again, some of those theorem names are arbitrary, all right? They're based on the book we are using. So if angles are supplements of same angle, then they are congruent. Done. Okay? But now, how does that help us? Look at angle 1, look at angle 7. They're congruent. All right, think about it for a second. What kind of angles are those? Those are corresponding angles. So I have two corresponding angles that are congruent. Can I say the lines are parallel? And the answer is yes. So M is parallel to L. And how do I know? Well, it was that converse that we just talked about earlier in this lesson. Okay, corresponding angles are congruent. The lines are parallel. And yeah, do I have the situation that I need for that? Yes. Okay, so simplify it a little bit. Just say if corresponding angles congruent, then the lines are parallel. Okay. We're doing the same thing, but in reverse. In the previous lessons, we were looking at, okay, these lines are parallel. What does that tell me about the angles? What can I prove about the angles? Now I know stuff about the angles. I know stuff about the properties of what's going on. I want to work backwards to prove that the lines are parallel. Okay?